Hey folks, Kevin here. Well, it's August 19th, 2020, and today what I'd like to do is talk a little bit about greenhouse construction and all. Now, I have a whole series of videos starting off back in 2012, I think it was, with our Harbor Freight experiment. We purchased a 10 by 12 thin-walled polycarbonate an aluminum greenhouse from Harbor Freight. We put a 275-gallon water tote in it as a heat sink. I did have supplemental heat for it, and we did use it as a season extension growing system, and that's attached to our house still at this point as well. And there's videos on that as well. Then ultimately we started planning. We knew we wanted to have a greenhouse, and I had been doing research for years. And before this, we built a passive solar home many years ago in the early 80s. My brother's an engineer. I am not an engineer. I'm a clinician, now a farmer. And the passive solar home worked out extremely well. And one of the things, not only is it super insulated, and it's designed so the majority of the windows in the house are on the south side of the house. We only have one window on the north side of the house. We have a significant overhang on our house. We have shade trees in front of the house. We have a large thermal mass unit with a masonry structure and wood stove for conveying heat into our thermal mass unit. And I've made videos on all of those topics in the past as well, and done several different Ask Me Anything videos as far as the energy efficiency, how much we saved over these last few decades and all, and that was enough for paying for the house a couple of times over. By saving heating and cooling costs. So that's really worked out well. Then we had been researching, incorporating the knowledge that we had from experience of building a passive solar home with a large thermal mass unit underneath the ground of the house, and developing other energy efficiency systems that we've implemented in the house as well. And then on site we have a large photovoltaic system, so that's solar panels that convert sunlight into electricity, and that meets all of our electrical needs on the property, and then some. We're over 30 megawatts ahead of what the utility is used on us, or what we've actually consumed over this last since 2012. So we've had really good fortune in carefully planning our systems as time has gone on, and subsequent to that we decided, geez, I was going to build a chicken coop and work area, which I'm in right now, the work area, and the chicken coop's behind me. But it's super insulated. It has insulated concrete form foundation. It's insulated below ground, and an attached greenhouse is going up against it as well. And that has the large thermal mass unit built into the basement of it with wash stone where air flows in between it. And I've created a whole series on this. In the center of the greenhouse are numerous 275-gallon water totes. So we have two different means of storing energy. And as a result of, I guess, the videos that I've been producing and the website that we have, I get questions from time to time about what do I think about different aspects of elements being incorporated into a greenhouse design. So Raphael recently emailed me and wanted to know if I could contribute by running over topics, running over some of the ideas that he had. So like one is his thermal mass using the University of Minnesota, using shallow rock bed as a system, which I haven't investigated yet, a geothermal heat sink using underground drain pipes as well, or direct sunlight heating, black painted 55-gallon water totes. And all of these systems have been around for many decades, and they all work well. However, goals and context need to be are really the foundation. If you're going to build a building, you need a really good footer to build the foundation on, and really your goals, your aspirations, your dreams, and the context of your circumstances are essential for ultimate success. And certainly another thing that I've talked about in many videos before is the triad. You can have any two out of the three. So time, cost, and quality. So if you want high quality and you want it done quickly, it's going to cost you a lot. If you want something done inexpensively and you want it up quickly and you want it and you want low cost, then the quality isn't going to be that great. So those are things to think about and to be aware of. And so what I usually do is I go ahead and I ask the people questions. Because before I can make a plan, I have to assess the situation. And before I assess the situation, I need objective data and subjective data. We call that SOAPing in medicine. So subjective, objective, that's measurable things. These are the things you think you want. These are the things that you believe are going on. Objective data, and I'll get into some of that momentarily. And then you can assess things based on that and create a plan which can be modified as new information becomes available, or you realize that the system that you're designing wasn't exactly what your ultimate dream was. And before I go any further, I'm not an engineer. I'm a trained veterinary internist. I'm a forever student, so I'm always doing research on whatever the topic is. And I'm not fast at these things. This has taken me years to really do the research as far as building extended season production or for a greenhouse for growing year-round. So, and one more thing I want to say is there is a YouTuber that I think is really good as far as explaining some really basic concepts, whether it's glazing of a greenhouse, thermal mass, footage, orientation, those sorts of things. His name is Rob Avis, and I think his wife is Michelle Avis, and they were, I believe, in Calgary, Canada. I'm not positive. This is terrible, but it's Verge Permaculture, and I'll put a link in the description below to Verge Permaculture. And I know that Rob had done an overview. Now, he's an engineer, and his wife is an engineer, and I think they came from the oil industry and then discovered permaculture, and really that's one of their businesses is permaculture design. And I think that consultations with greenhouses may also be a component of their business model. I'm not positive, but I'll leave a link to their website or their YouTube channel in the description below for this video. So I jotted down a few notes that I'm going to refer to, if I can bring those up in my Evernote, of how I actually go about starting any project. So the first thing is really just, throwing out all your dream concepts. It may be pictures that you've taken, or YouTube videos of other people's greenhouses, or magazine articles, or whatever it may be. Really trying to think what it is that your goals actually are, your dream greenhouse. And context means everything. So your goals may be to grow in a cold climate, tropical foods, tropical plants. You may want to just have a microgreen business and sell locally to local farmers. And so the orientation of how close you are to the shops that you're going to sell to the stores you're going to sell to the farmer's market, whatever it is. So your context is everything. It may be that you're retired and you want to have a beautiful greenhouse to have a hot tub in or a small pool in, and you're only going to use it a few months of the year. You may want to use it as a season extension, so you don't want to pay a heating bill. And so let me say this as well. If for terms, the term that I like, the description that I like to use for greenhouse, it means that we're using a heating source in a cold temperate climate like we're in Oswego, New York. So our two biggest problems are excessive heat in the summertime and inadequate heat during the winter months. So we need to be able to cool the building. If we're going to do year-round growing in it, we need to cool the building and shade the building during the summer months, and we need to provide supplemental heat. Now that can be solar heat, and of course all greenhouses are solar in respect to, yes, the plants use photosynthesis in order to grow the plants. However, when we say a passive solar greenhouse, we're talking about using additional resources in order to heat that greenhouse. And this video isn't going to get into all those. I've gone over these things in other videos in the past. But context and your goals matter, and that's where everything starts off. So do you want to have year-round production, or do you want to have seasonal extension? So I've posted several videos on the on the Gothic greenhouse, but it really isn't a greenhouse because it's not going to have supplemental heat. It's a Gothic shaped high tunnel, which is basically galvanized pipes that have been bent, and they stick in the ground and they come to a peak, and you use polycarbonate plastic over it, or double-walled polycarbonate plastic over it, and with a squirrel cage fan that can blow air in between the two layers of plastic and provide a level of insulation. And that can assure you, so this time of year I could be planting crops inside of that extended grow season area. The plants get to a certain level of maturity, and when all the snow hits us and all, I could go out into that high tunnel or Gothic greenhouse, whatever you want to call it, and go out and harvest the carrots, the kale, all of those materials, all of those plants that can survive during the winter months and still be viable with either having different growing zones inside of that high tunnel. And I've talked about that in other videos, the difference between low tunnels, high tunnels, the combination of using different growing structures within a greenhouse as well. And that's something I'll be doing in the future with our greenhouse. So do you want to have extended season? That doesn't mean every month that you're growing something. It means that, geez, right now if you just have outside gardens here where we're located, once the frost comes, everything's dead out there, and you've got to wait until next summer or late spring before everything gets to being produced in your gardens before you can start harvesting it and using it. Extended growing season means you can plant a late summer crop to develop during the fall and then be harvestable throughout the whole winter months. Excuse me. So what do you want to grow? So is it season extension, or is it all year round? What do you want to grow? Do you want to grow citrus? Do you want to grow orchids? Do you want to grow microgreens for sale? Is this an adjunct to a community-sponsored agricultural system, the CSA? What is it you want to grow in there? Because those growing conditions and things like the rest of the context, your topography, the climate, and all of those things, you have to come up with the right formula. So, and how much do you want to grow? Besides, what do you want to grow? What will meet your needs or your dreams? Your climate. So, we live in Oswego, New York. So we're in a cold temperate climate. But just 30 minutes south of us, the growing season is a month longer. 1 hour south of us, the growing season is 2.5 months longer than ours. And for a greenhouse where we live, so we're just off the south shore of Lake Ontario. So Lake Ontario is a large thermal mass unit, big, large body of water, and we're in amongst the Great Lakes. So when we get our winds out of the north and out of the northwest, those cold winds come over that warm lake, pick up all that moisture, and create clouds that cover us. And we also get lake effect snow. So we have the high winds during the winter months, we have the cloud cover, and we have snow loads. So I mentioned previously that we have a large photovoltaic system that we've shown in many videos. And I've created videos that tell you how to calculate how many photovoltaic cells or the size of the system that you need to meet your needs. It takes you right through step by step how to calculate that. So we have this large solar panel array, 2 of them, that really meets our needs for our whole year and produces excess energy. But during those cloud-covered and snowy winter months, we produce a small fraction of what we produce the rest of the year. So 1/4 of our season produces less than 8% of our energy. And that relates to the greenhouse, because that's really dependent on our additional heat generating system, besides the photosynthesis coming through the glass or coming through the polycarbonate or Solex or whatever the material you're using. Aside from that, there's going to be a lot of heat loss during those evening hours or cloud cover hours or snow covered hours. So lighting is an issue for us if we want to be actively growing things in the greenhouse during the winter months. Certainly heat is a big issue, so we have to have additional redundant heating sources for our greenhouse. Need to do overkill, just like we had to do for our photovoltaic system. We need to do that as well. So, and I'll just give one example. So I have several solar thermal heaters. Now when people talk about solar panels, they're usually referring to the photovoltaic ones, the ones that take the energy from the sun and turn it into direct current, and then it gets turned into alternate current for in your house. What I'm talking about when I say solar thermal, they could be water tubes that are filled with an antifreeze-like substance, and that gets turned into heat energy, and that hot water can get pumped to your large water totes in your greenhouse, or to barrels in your greenhouse, or it can go into radiant floor heating systems, or the other type of solar thermal, which is less expensive and really productive, are hot air producing ones. And I actually have a few listed on Craigslist now, 4 foot by 8 foot. And these systems were Jimmy Carter had these systems put on the White House back in the 70s, and they work extremely well as long as you have the sunlight exposure, and these units are insulated. When it's a sunny day, they generate tons of heat, and you pump it into your house or pump it into your greenhouse. And the thing is that they don't actually have to be attached to your building as long as you design your heat transfer system effectively. So we have several ways, and you can use other heat sources that don't use electricity or don't use fossil fuels. Another one is using compost. Many years ago, when we had a horse farm, one of our friends who was a breeder, and she had a large stable where she leased stall space to tenants for their horses. Well, she'd take all that horse manure and she'd use piping and capture the heat from that compost and use that to heat her house as well. So you can use compost heating systems to heat water or heat air as an adjunct heating source for your building. You can use rocket mass heaters, and you can use other types of wood burning systems as well. I'll be going over in the future, and I've talked a little bit about our heating systems that we'll have for this greenhouse and what the plans are. And ours isn't attached. It's attached to the building that I'm in right now. And that allows me to experiment with different systems to help meet the heating needs in that greenhouse structure. And I'll elaborate on that in future videos. Topography, that's important. Not only is the part of the world that you're living in, whether it's a tropical environment, desert environment, a cold temperate climate, that's important, but what about the topography? Are you in a mountain range? Are you in the plateaus? Are you in the plains? Are you in the valleys? where are you located, because that's extremely important. The climate that you're in, the topography that you're in, what, you know, if you're in the northern hemisphere, what's facing south to you? Is there a big mountain? Are there big buildings and all? Those are important things. Then we get into microclimates. So microclimates, like we have the high snow loads here. Fog can be a major issue. Topographic shadows that would shed light on the cast shadows on your greenhouse during the lighted days. High winds, hailstorms, ice storms. So you really need to do the research, in my opinion, to look at those things that can have a negative impact on your ultimate dream of the efficiency and maintenance or resiliency of the greenhouse structure that you're thinking about. So those are really important. The latitude. Latitude is really important, not just for the climate that you're in, but it also determines the orientation of the greenhouse. And it also tells us about the reflection of the glazing materials that you're going to have as well. So above the 40 degrees latitude like we are here, it's best if your greenhouse isn't oriented like ours is. Our peak and is facing north and south. And I'll go over that in future videos, why we elected to go with that system. But the most efficient orientation is to have the long axis of your greenhouse facing south, with one or two glazing surfaces facing south, with a proper orientation for both winter and summer sunlight as well. And it really depends on your latitude how you choose this system. And that's even comes before we talk about the glazing materials, the polycarbonate, the double layered, the thickness of the polycarbonate, the Solex, the glass, the double pane glass, the polyethylene clear plastic, the double layer with a squirrel cage, putting air in between the two layers of the plastic. All of those things you can do cost and efficiency and resistance to heat loss, all of those, the R factor. You can look at a comparison of each one of those, but before you do that, you really need to know where you're located and the best orientation. So the longer the building is, maybe 3 times longer than the depth that you're heating the structure or growing in. Like a 3-to-1 is what some people recommend. And do you have the ability on your property to do some of it subterranean? So in other words, you're using some of the thermal mass of the earth that's around you, and you're sinking your greenhouse into the ground, and therefore have more insulation in a sense, and less of a chance of heat loss. And that depends on your water table. Is there bedrock where you're located, limestone? All of these things need to be researched. So you do your subjective analysis and your goals and aspirations. You do your data collecting, get your objective data. Then you can assess your situation and then ultimately make the plan for your greenhouse. Freestanding versus attached. Now our greenhouse is attached, and that offers us a lot of possibilities, but it's not attached to our house. So I've seen greenhouses that were attached to their houses, or solariums that are attached to houses where there's mold problems because of the moisture in these greenhouses, whether there's a pool, a hot tub, plants in there that are being misted or that are being watered regularly. You can have air quality issues and health issues associated with an improperly attached growing structure, greenhouse, to a home. We knew about all these things. My whole background is in medicine, and so we took all of these things into consideration. And this is a super insulated building that we're in. And we can, if we wanted to, we could hook an electric dryer here and pump the heat into the system. We can use a solar dehydrator to take that excess of heat and accomplish other tasks throughout the season as well. So there's and there's a multitude of other issues as well that we can do. So this allows us to have more thermal mass if we choose to in an additional structure to save for those long periods without the sun, all the cloud cover as well. So freestanding or attached. And freestanding gives you other opportunities, but then you have that north face, if you're in the northern hemisphere, that you really need to insulate so that you're not having so much heat loss. That's if you're any place that's cold like we are. Financial concerns. So are you trying to do this in an area where there is a homeowners association, where you need to take into consideration taxation? Is this part of a business? What about zoning and planning boards? What about fire codes? What about setbacks, property line issues? Getting all those things straightened out before even applying for a building permit to put your season extension. Now, your high tunnels and low tunnels usually don't need, and now there may be exceptions to this, don't need a building permit. Now, certainly if you're in a residential area, you may not even be allowed to put those in, but they aren't going to require all the hurdles that you have to do in order to put something in that's permanent. Nothing's permanent, but it seems like it's fairly permanent. So access to water and power. These are things that need to be considered as well. You need to have a water source for your greenhouse. You need to have a power source. You may want to have a data cable. Like for our greenhouse, this is going to be not just automation, but it's going to be an AI system. So we're going to use some artificial intelligence systems that are being developed at this time to help regulate the systems in here. Just not, oh, if this temperature hits this or this wind comes from this direction, close these vents, leave the other vents open. We want it to be much more efficient ultimately and require less physical labor in this system as well. And size of your growing space. Once you know what it is that you want to grow and you've got an idea about things, you need to do, if it's a business, do a cost and profit analysis. You need to say, geez, you know, if I make the greenhouse bigger, it's going to be more efficient, but will I be able to sell that much produce, and so on and so forth. So those are all things to consider. And I'm sorry I'm not going over the thermal mass, the rock beds, absorption, convection, conduction, and radiation. Those are the three physics properties of transfer of heat and all. And those are all things that need to be taken into account. The pipe size, the angles of the fittings of the pipe sizes, the very gentle slope. If you have a right angle, well, you're really increasing resistance. Most of the greenhouse subterranean piping systems that I've seen are not very efficient. The penetrance of the tubes to the amount of soil around the area. Yes, we can use convection currents going through the pipes, but how much heat is transferred at what levels to different soil or water or rock in the area? How do we increase absorption into these other surrounding thermal mass units that aren't being utilized? Well, instead of blowing air, we need to be sucking air, and that needs to be regulated by thermal sensors in different locations, and then basically it has to circulate around the building. And I've yet to see what I would call a more efficient thermal mass utilization system using the appropriate electronics and proper spacing and airflow rates to maximize absorption into the media that you're trying to transfer that heat energy from your convection currents that were originally radiant heat. So your radiant floor, that sort of thing, surface, and then the air system that gathers and goes to your peak, and you want to suck that heat source in. But then when you run it through your pipe systems, do you really want to be pushing it through where it's going to take the path of least resistance, and a lot of the thermal mass is not utilized very well. And I like redundancy. Like I said, we have water totes and we have the thermal mass, and we're super insulated. We have 3.5 inches of dowel board below the rock surface on top of the ground here. when we look at our root cellar and we see just how well that temperature is regulated at 7.5 feet below the surface of the ground, the temperature is perfect all season long, and we're about 50 degrees, 54 degrees in the summertime, 50 degrees in the wintertime, and that's absolutely excellent. Well, that ground temperature is going to be very similar at a similar depth in this area here, but I don't want to be taking my heat from my greenhouse that I'm gathering or any other source and dump it into a system where the heat dissipates into the... Well, I just looked up and saw that the camera said I was maxed out on time on here, and it stopped recording at some point. So wherever I left off, I'm sorry that I truncated the video at this point. But hopefully the basics of that initial, the goals and aspirations and the context of where you want to put this greenhouse, your own situation, and that's financial. Like I mentioned early on in the video, the time to get the structure up, the cost, and the quality are all three tightly associated to one another. That's why it's taking me more time to get this done, is because I'm basically doing it by myself, and I really want super high quality, and I don't want high cost. So those are all the relative features of factors of why this is taking me so long, and I'm a little slow. So if you found this video of value, please give us a thumbs up, share it with your friends if you think it's of value, and by all means, take good care of yourselves and stay healthy. We all need to do that. Self-care is really important. Take good care of yourselves, folks, and have an awesome day. Bye-bye now.